Same thing as the previous video, we are going to use here the angle addition postulate. But it's very specific for this practice exercise because of the notation here we found in our angle. This notation here marks, or these notations rather, shows that the angle BAT represented by 3x minus 10 is equal to the measurement of angle TAG represented by measurement x plus 40 degrees. In short, ray AT is considered to be the angle bisector. If we talk about angle bisector, it is a ray that divides an angle, not necessarily just a ray, a line, or a line segment that divides an angle into two equal parts. Equal parts meaning they are congruent and they have the same measurements. The notations that are used here are the number of arcs found. If this has two arcs and the other one has one, then we cannot determine the value because this is not anymore an angle arc, or rather ray AT is not anymore an angle bisector. But since it has same number of arcs, one and one, this is enough for us to consider that this ray AT is an angle bisector and that two measurements are equal to one another. In this case, we could say that the measurement of angle BAT is equal to the measurement of angle TAG. We will be using this to solve for the value of the unknown variable, which would actually be helpful for us in solving the other measurements here. Let's start by substituting the value for measurement of angle BAT as 3x minus 10 degrees. And the measurement of angle TAG is x plus 40 degrees. To solve for this, simply use the different properties of equality. Let's start with adding both sides by 10 degrees. So that the 10 here, negative 10 rather, will be simplified into 0. So we also add here 10 degrees. And by doing that, you have 3x is equal to x plus 50 degrees. And then we subtract both sides by x. Again, add 10, add 10. Here, let's use different color. Subtract by x. And the other side will also need to subtract x so that what's left would be the constant, 50 degrees. So this is actually equivalent now to 2x is equal to 50 degrees. And divide both sides by 2. X is 25 degrees, right? We could use this value to solve for the remaining items. Well, we could check it first, but by checking, we could also determine later on after solving number 3. So let's try to use here the value of x to the measurement of angle BAT, which stands for 3x minus 10 degrees. Simply substitute the value of x being 25 degrees minus 10 degrees. That's 3 times 25 is 75 degrees minus 10 degrees is equal to 65 degrees. This is the measurement of angle BAT. Let's continue in solving angle TAG, or the measurement of angle TAG. And then pause before moving to number 4. Let's verify if they are really equal, okay, using this value so that we will be assured first. So measurement of angle TAG is given to be x plus 40 degrees. The value for x is 25 degrees. So you have 25 degrees plus 40 degrees will stand for 65 degrees. This is the measurement of angle TAG. As I have mentioned earlier, before moving to angle to number 4, which is the measurement of the largest angle, the combination of both angles here, let's check first if the value of x, which is 25 degrees, could satisfy the given that these two would be equal measurement under the angle bisector here. To show that, let's simply equate them. You'll have measurement of angle BAT. This is checking, by the way, should be equal to the measurement of angle TAG so that we could actually assume bisector, an angle bisector. So measurement of angle of BAT is 65 degrees. TAG is also 65 degrees. That's correct. After using this value, that would mean this is already the checking for items 1, 2, and 3. Now that we are sure with the value of x and the value of the different angles here, comprising the biggest one, we could solve that biggest one using the angle addition postulate, which tells us that the measurement of the largest angle, in this case, angle BAG, is the sum of the measurement of angle BAT and measurement of angle TAG. Angle BAT is given to be or is computed to be 65 degrees, and we are already assured with that. And measurement of angle TAG is also 65 degrees, to which we're already assured with that by this checking. So we have here 130 degrees for the measurement of angle BAG. Again, this is still under the angle addition postulate, but it's special because of the assumption of angle bisector. Okay, angle bisector divides the biggest angle, angle BAG in this case, into two equal parts. And we did that, use that relationship to solve the unknown, which actually helped us to solve for the rest. So please try to remember the concept of angle bisectors. It may come out a little bit later in a part of our discussions or soon in your other higher level mathematics. So please consider the angle addition postulate and the concept of angle bisector. The next video will cover the other angle pairs. So please be excited and see you. Watch out for those videos. Goodbye.